Hello. Hello, Rohan. Am I audible? Hello. Hello, Neha.
Sir?
Am I audible? Am I audible?
Yes, sir. Yes, sir.
Okay. Screen is visible to you?
Yes, sir.
Okay. Okay. So in the previous lecture, we have started with the static error constant for different types of system, type 0, type 1, and type 2 system. And we have solved simple problem based on that method. Okay, so we are in this lecture, we are going to solve more problems based on that. Okay, so take down the next problem. Okay, so this is the problem statement for the unity feedback system. The transfer function is given g of s equal to 40 into s plus 2 upon s into s plus 1 plus s plus 4. Find number one type of system, number two all error coefficients, number three steady state error for ramp input with magnitude equal to 4. So try to solve this problem. Please note down this. So write down the solution. So here in this problem, we have to find the type of the system. Okay. So first you find type of the system. Okay. So how to find type of the system? So this is the transfer function given to you. Open loop transfer function. U of s into h of s. So here h of s is unity. That is unity feedback system. That's why h of s is 1. Okay. So for type of the system, what parameter we have to identify in the transfer function? What will be the first step? Yes, anybody? So first of all, convert
Maximum
your
power of 10.
right. So convert your transfer function into standard time constant form. Okay. So once again, I repeat the standard transfer function. Your transfer function can be expressed in two forms, either in time constant form, either in full zero form. Okay. So for as far as time response analysis is concerned, we are always converting our transfer function into a time constant form. And what is time constant form? So standard time constant form is like this: a into 1 plus e z1s into 1 plus e z2s upon s raised to n into 1 plus e p1s into 1 plus e p2s, like this. So this is the standard time constant form. So you just convert your transfer function into given form. So here what is given? G of s into h of s is given. Here h of s is 1 because here they have given the unity feedback system. So h of s is considered 1. So it will be given 40 into s plus 2 upon s into s plus 1 into s plus 4. So whether our transfer function is in time constant form. So in which form the transfer function is given? It will be given in the pole zero form. Okay. So what is pole zero form? G of s into h of s. It will be given by k times s plus z1 plus s plus z2 upon s raised to power n into s plus p1 plus s plus p2. So this is in pole zero form. Okay. So our transfer function is given in pole zero form. Okay. But for finding out the error coefficient, we require our transfer function to be converted into time constant form. So therefore, we are converting our transfer function into pole zero form. Sorry, time constant form. And from this expression, you can directly find order of the system. Here you see this s raised to power 1. So therefore, order of the system is here n is equal to 1. So the type of the system is type 1 system. Is it clear? So first of all, convert this into time constant form in this form. So what we are doing, Here simply g of s into h of s equal to, so we are just taking 2 common from this numerator. So here is 40 into 2. ये बचेगा आपका, if you take 2 common, so it would be 1 plus here 1 by 2. That means here is 0.5 s upon यहाँ से, so this is already in 1 plus s form. So take 4 common from this second term. So if you take 4 common, so here is 4 s raised to power 1. Here is 1 plus s in bracket into 1 plus 1 by 4s. Okay. So what is the value of 1 by 4? It could be 0.25. So you can write down 0.25s. Okay. So you just simplify this. So this 2, so it could be 20. So 20 into 1 plus 0.5s upon s into 1 plus s into 1 plus 0.25s. This is our g of s, that is in time constant form. So now compare this equation with this equation, equation 1 for this, equation 2 for this. So if you compare, find the value of s raised to power n. So here s raised to power n is 1. So therefore, as here n is equal to 1, so therefore it is a type 1 system. So this is our first answer. Then find second. Second, you have to find error coefficient. Okay. So find first error coefficient for static error constant for unit step input. So find the value of Kp. Kp is the positional constant or positional error coefficient. Okay. So tell me the formula of Kp. Kp will be given by limit s tends to 0 G of s into h of s. Okay. So now substitute the value here. So Kp is equal to limit s tends to 0. Substitute the value of g of s into h of s, that is equation number 2. So it is 20 into 1 plus 0.5s upon s into 1 plus s into 1 plus 0.25s. So substitute the limit and find the value of Kp. When you substitute the limit s tends to 0, here is 1 by 0, so therefore you will get Kp is equal to infinity. Similarly, you can find the value of Kv. So for ramp input, we have got velocity error coefficient. Okay. What will be the formula of KV? Yes. What is the formula of KV?
Limit s tends to 0, s into g of s into h of s.
Right. Limit s tends to 0, s into g of s into h of s. So substitute the value and tell me the value of KV. So limit s tends to 0, s into the g of s value 20 into 1 plus 0.5s upon s into 1 plus s 1 plus 0.25s. So this s get cancelled. So when you substitute s is equal to 0, this term becomes 0, this term becomes 0, this term becomes 0. So it is only 20. So write down KV is equal to 20. Similarly, you can find the value of third constant or error coefficient corresponding to parabolic input. So which type of error coefficient we got for parabolic input? That is acceleration constant or acceleration error coefficient, AA. Okay. So it will be given by limit s tends to 0, s square g of s into h of s. So substitute the value and find the value of Ka. Okay. So it could be limit s tends to 0, s square here 20 into 1 plus 0.5s upon s into 1 plus s into 1 plus 0.25s. So this set gets cancelled. So 1 s in the numerator. So when you substitute s is equal to 0, it could be 0. So therefore here we are getting Ka is equal to 0. So this is our second answer. All the error coefficient. That is positional error coefficient, velocity error coefficient, and acceleration error coefficient. यहाँ तक किसी को डाउट है? Now next, that is third answer. अभी थर्ड क्या फाइंड करना है? Error for ramp input with magnitude is equal to 4. That means error means what? Steady state error. एक ही error है अपने पास में. So we have to find the value of ESS. Then what is the input? Input is R of t and its magnitude is 4. So that means input is 4 times t. Okay, so this is the input given to us. And for this input, we have to find the value of ESS. Okay. So what is the value of ESS when ramp input is applied? ESS क्या रहता है रैम्प इनपुट के लिए? रेफर द टेबल.
One by KV.
1 by
KV.
Right. So it will be given by 1 upon kV. But for that purpose, here we have assumed what is the value of ramp signal. We have assumed it is 1. Okay. So here what is the magnitude given? That is 4. So in general, we say that the steady state error for ramp signal is given by A by kV. Okay. And here the magnitude is given 4. So therefore 4 by kV. Okay. So therefore substitute the value of, we have already find the error coefficient for different input, unit step, unit ramp and parabolic. So input is given, that is ramp input, and for ramp input we will get the error coefficient kV, and here kV value is 20. Okay, so therefore we just substitute this value. So 4 upon kV. Okay, so here 4 by 20. Okay, so it could be, what is the value of 4 by 20? So it could be 1 by 5. So that means it is 0.2. So when we apply a input of 4 times ramp signal, okay, so at that time steady state error could be 0.2. So this is the problem. So similar type of problem can be asked in the examination. Only little bit changes will be there. Okay, but these are the steps to solve the problems based on static error coefficient with different types of the system. तो आपको पूछा जाएगा what will the type of the system, find the error coefficient and find the steady state error for this type of input. Sometimes the combination of input signals are given, that is ramp plus step or ramp plus parabolic, like this. Okay, so we'll solve certain problems like that also. Okay, to take down another one. Okay, write down. For a system G of S into H of S will be given by K upon S square into S plus 2 into S plus 3 . Find the value of K . Find the value of K to limit a steady state error that is ESS, steady state error, to 10 when input to the system is 1 plus 10t plus 40 by 2 t square. So this is the problem. For a given system, that is open loop transfer function G of S into H of S will be given to you. So that is K upon S square plus S plus 2 into S plus 3. So for the system, find the value of K. Here we have to find K to limit the steady state error ESS to 10 when input to the system is 1 plus 10t plus 40 by 2 into t square. So this is the input applied. So when this input is applied to the system, it will give you the steady state error to 10. And when we kept steady state error to 10, we have to find the value of this k. When we limit steady state error to 10, what is the corresponding value of k? So that we have to find. So in the previous problem, the value of k is given to you. Okay, so if you consider the previous problem, so this 20 is the value of k. Okay, so here the k value is unknown, that we have to find out. So tell me the process. First of all, write down the given data. Write down the given data. What is given? That is steady state error is limited to 10, and when input is here r of t is given 1 plus 10t plus 40 by 2 into t square. Okay, so here as input is a combination of three different input, three different input with different magnitude. Okay, so which are the magnitude of your signal? Let's say A1 signal. So this is A1, this is second signal, this is third signal. So A1 is 1, A2 is so here A1 is 1, A2 is 10, and the third constant, that is A3. Okay, what is the value of A3? It is 40. So these are the constant magnitude of the constancies of the different input. First input is unit step, second one is ramp, third one is parabolic. So here the combination of these three signals are applied to the given system. Okay, so these are the inputs, and for this input we have to find the value of k, so that we have to limit the steady state error to 10 only. Okay, so how will you find it? Yes, how to find the value of k? क्या करना पड़ेगा? जैसे हमने प्रीवियस प्रॉब्लम सॉल्व किया, similarly here same way you can solve the problem. Okay, so in the previous problem, first of all we have find the type of the system. Okay, so here again you can directly identify the type of the system. It is a type 2 system. Then second step we have find the error coefficient. So same way you can find the error coefficient, and at last you can find the value of steady state error. Okay, and from the steady state error you will get the value of k. Okay. Okay, so let's determine first the error coefficient. Error coefficient. Okay, so find out first kp value. Tell me the value of kp. So in order to find kp, again you have to convert your transfer function into time constant form. Okay, so first convert your transfer function into standard time constant form. So here is k. So k upon s square into, इसमें से मैं कॉमन ले लेता हूँ 2, हियर इज 2, ये टर्म में से कॉमन ले लेता हूँ 3, हियर इज 3, तो बचेगा 1 प्लस s बाय 2, 1 प्लस 3, so 2 into 3 6, so it could be k by 6 upon s square into 1 plus what is the value of 1 by 2? So you can use this like this, yeah, s by 2 plus s by 3. So this is your g of s into h of s in the time constant form. Okay, so now find the value of kp, error coefficient. Use the formula limit s tends to 0, g of s into h of s. Okay, so here again, if you want to identify the type of the system, so it is here n is equal to 2, therefore it is a type 2 system. So substitute the value in this expression. What is the value? Here k by 6 upon s square into 1 plus s by 2 into 1 plus s by 3. So now substitute the limit s tends to 0. Here is 1 by 0, so it could be infinity. So kp is equal to infinity. Please verify this. Similarly, determine the value of kv. So again, write down the formula of kv is limit s tends to 0, s into g of s into h of s. Okay, so s multiply by this term k by 6 upon s square into 1 plus s by 2, 1 plus s by 3. So this 1s get cancelled, and when you substitute s tends to 0, here is 1 by 0, again infinity. So therefore second term also we will get infinity. So again kv is equal to infinity. Then find out third ka, limit s tends to 0, s square g of s into h of s. Write down this formula. Then substitute the limit So k equal to limit s tends to 0, s square g of s into h of s, it is k by 6 upon s square 1 plus s by 2 1 plus s by 3. So this s square get cancelled, and when we substitute s is equal to 0, here is this term gets 0, this term gets 0. So here we are getting simply what is the value of k? So it could be k by 6. So k equal to k by 6. So here we have got all the error coefficients. Now last, what we have to find? We have to find the value of k. To find the value of k, last one is the steady state error. So what is the expression for steady state error? When input applied to this system is 1 plus 20 plus 40 by 2 into t square. Okay, first input is step, second है ramp और third है parabolic. ओके सो स्टेप इनपुट से एक ईएसएस ऐड होगा, रैंप इनपुट से अप्लाइड करने से सेकंड ईएसएस ऐड होगा, पैराबोलिक इनपुट अप्लाई करने से अनदर ईएसएस मिलेगा. विल गेट द डिफरेंट वैल्यू ऑफ ईएसएस फॉर डिफरेंट इनपुट्स. यू हैव ऑलरेडी गेट द वैल्यू ऑफ ईएसएस फॉर डिफरेंट इनपुट्स. Okay, so therefore total steady state error will be given by what? It is the algebraic sum of the steady state error obtained due to input 1 plus steady state error obtained due to input 2 and steady state error obtained due to input 3. So total ESS will be given by ESS 1 plus ESS 2 plus ESS 3. ESS 1 मिलेगा आपको because of the step input, ESS 2 मिलेगा because of the ramp input and ESS 3 मिलेगा because of the parabolic input. Am I correct? Because here we have applied input R of t is 1 plus 10t plus 40 by 2 into t square. Okay, so when we apply such type of input, the total ESS is limited to 10. So therefore here total value of ESS we are limiting it to 10. Then when step input is applied, what is the expression for steady state error? It will be given by A upon 1 plus Kp. Am I correct? So here we will consider A1 plus what is the value of ESS2? That is the steady state error because of second input, that is ramp. So it will be given by its magnitude is A2 by kV, because kV is the error coefficient for ramp input. Then third A3 upon Ka. Okay. Now substitute the value of Kp, Kv, Ka in this expression and find the value of K. So here we are getting 10 equal to, what is the value of A1 is 1. So here is 1 upon 1 plus what is the value of Kp? Kp is infinity plus A2 is again 10. So here is 10. Kv value is infinity. So 10 by infinity plus A3 value is 40. So K value is K by 6. So here is K by 6. So 1 by infinity is 0. 10 by infinity is 0. So therefore here we are getting 10 is equal to 40 upon K by 6. So find the value of K. Tell me the value of K.
$24.
Right, 24. So how it is? So 6 into 40, it is 240. So 240 divided by 10. So that is equal to 24. So K is equal to 24. So when we substitute k is equal to 24, at that time our steady state error is limited to 10. Then this input is applied to the system. Okay. Ritesh Chauhan, please mute your mic. To take down another one. Write down. For a unity feedback system, the value of G of S equal to 8 upon S square into S square plus 4S plus 8 into S square plus 3S plus 12. Determine the error coefficient with the input given by number 1 R of t equal to 5, number 2 R of t equal to twice t, and number 3 R of t equal to t square. To try to solve this, first of all, read the problem carefully. And then try to solve this. So what we have to find? We have to find the value of error coefficient with the input given by. So first input is R of t equal to 5. Second is R of t is 2t, and third one is R of t is t square. Okay, tell me how to find it. So what is the type of the system? Can you identify the type of the system from this G of s into H of s? Here H of s is 1. Yes, anybody? So here G of s into H of s, here H of s is 1, so only G of s. So here it will be given by 8 upon s square into s square plus 4s plus 8 s square plus thrice s plus 12. And what we have to find? We have to find the error coefficient. Okay. So how many error coefficient we have? We have to find the error coefficient for different types of input. Okay. So inputs are given to you. First input is the step input. Second one is ramp input. Third one is parabolic input. So let's say for first input, when input is ramp, that is R of t is equal to 5. So what is this R of s? So R of s will be given by 5 by s. Okay, so it could be 5 by s. So for ramp input, for step input, which type of error coefficient we got? For ramp input, we are getting the value of Kp. That is positional error coefficient. Write down this positional error coefficient. Okay. So what is the value of Kp? So write down the Kp formula. Limit s tends to 0, G of s into H of s. So tell me the value of Kp. So what are the factors of these two terms? S square plus 4s plus 8 और s square plus thrice s plus 12, इसके कुछ फैक्टर गिरते हैं क्या? Yes. Tell me the factors of this s square plus 4s plus 8. So tell me the value of Kp, Ka and Kv. Substitute the value. Limit s tends to 0. G of s into h of s is this. So 8 upon this term s square plus 4s plus 8 s square plus thrice s plus, when you substitute s tends to 0, here is 1 by 0. Okay, whole term is 1 by 0. Here is Kp is infinity. Similarly, you can find Kv. Limit s tends to 0, s into g of s into h of s. So when you substitute here, limit s tends to 0, s into g of s is this 8 upon s square plus 4s plus 8 into s square plus thrice s plus 12. So 1s get cancelled. So when you substitute s is equal to 0, 1 by 0. So here is 8 by 0. So here again we are getting Kv is equal to 1 by 0. So it is infinity. Then third one, that is Ka. Limit s tends to 0, s square g of s into h of s. So k equal to limit s tends to 0 s square 8 upon s square into s square plus 4s plus 8 into s square plus thrice s plus 12. So this s will get cancelled. So when you substitute s tends to 0, this term 0, this term 0, this term 0, this term 0. So here a is equal to 8 by 8 into 12. Okay. So here is 8 by 96. So here is 8. So it could be 1 upon 1 by 12. Okay. So this is the required expression for KA. So here we have determined all the values of error coefficient with different types of the input. So this is for tape input, this is for ramp input, and this is for parabolic input. Okay. So today we stop here. So in the tomorrow's lecture, we can start with the new topic, that is generalized error coefficient, and then so we are going to solve certain problems based on that. If you have any doubt, please you can ask.